Hello everyone. In this lecture, I want to talk about data visualization in Jupyter. Data visualization refers to a process in which we show data and analysis results in graphs or charts. Data visualization can make the communication very easy to understand among data users. It is very straightforward to show the data results to our data users. So in practice, data visualization is a very important aspect in business analytics. In this lecture, I want to use the fitness app dataset as an example to show everyone how to draw charts in Jupyter. We just created a variable called df to hold the contents from a fitnessapp.csv file. Let's take a look at this dataset. What we wanted to do here is to test how a user's yearly incomes, the number of gym visits, where he or she comes from, influence how long this user will use a fitness mobile app. We collected data from 100 users. When we bring in the data into Jupyter system, Jupyter will create an ID number automatically for each data record. But please pay attention to the ID number here. It starts from number 0. So the first customer will have ID 0. The second customer will have ID 1. The third customer will have ID 2, and so on and so forth. The ID just play a role as labels. It really doesn't influence our data analysis or data visualization. The important data are stored in the incomes column, gym visits column, state column, and hours column. In the last lecture, I taught everyone that df is a data frame. But a data frame looks like a table. Why we don't call a data frame a table? What is the difference between a data frame and a table? In a data frame, each column are independent, which means you can access to the data stored in different columns separately. For instance, I'm only interested in how long each customer used the fitness mobile app. I only want to access to data stored in hours column. Then this is what I can do. After df, I want to type in square brackets. Between square brackets, I want to type in 2 double quotes. Between 2 double quotes, I want to type in the column names. Let's type in hours, because this is what I'm interested in this case. And then I want to execute the code. Press Shift and Enter at the same time. Now you can see I only show the hours data in the data frame. If you are interested in incomes, then you can change hours to incomes. And then when you execute code, you can see each customer's yearly incomes data. If you want to see them all, just remove the square brackets and keep df. You can bring back the data frame. This is the key feature of data frame. This key feature made the data visualization very simple, very useful in Python. Let's say we want to draw some charts to show the key feature of data stored in hours. Before we draw charts, what we want to do is to import another library. Let's type in import, and then the library name is matplotlib. We also want to give it alias. Let's call this plt. This is a variable that has all the functions from a matplot library. Now we can draw charts or graphs for data stored in different columns. Let's say we want to draw a bar chart to show data stored in hours. What we want to do is to type in the square brackets and then 2 double quotes and then type in hours. Notice that if you want to access to the data stored in a column, the column name you type in here must be as same as the one stored in a data frame. So hours, H should be in uppercase. After hours, you want to type in dot plot. We want to draw a plot chart. And then parentheses. Between parentheses, you want to type in kind equals to double quote bar. This means we want to draw a bar chart for data stored in hours column. Let's execute the code. What you are seeing now is called a bar chart. On the x-axis, it shows each user's ID number. Because we have 100 customers, 100 ID numbers. But the picture is very small, so you really cannot see each user's ID number very clearly. In the future, if you have a bigger computer screen, if the picture is showed larger, you probably can see each customer's ID number. But remember, the x-axis here represents each user's ID number. The y-axis shows a range. It shows the range of usage in the dataset. From this chart, you can see a user could use the mobile app as short as about 4 hours. You see this 4 hours bar, right? As short as 4 hours. You can also see a user could use the mobile app as long as about 9.5 hours, as you can see here, the tallest bar. This shows the longest usage in the dataset. This example really shows the benefits of using data visualization. You don't have to look at the data records one by one in the dataset. From the bar chart, you can make a conclusion that these fitness mobile app users would use the app for about 4 and 9.5 hours. This is what you can get from this bar chart. You can also draw different types of graphs for the hours data. Let's say I want to draw a box plot chart. What I want to do is to remove the parentheses and then type in dot box parentheses and then execute the code. What you are seeing now is called a box plot chart. The bar at the bottom shows the shortest usage time. As you can see here, it's about 4 hours. The bar on the top shows the longest usage time. As you can see here, it's about 9.5 hours. The bar in the middle separates the dataset into half-half. About half of your users would use the mobile app lower than about 6.5 hours. About the other half of your users will use the mobile app more than 6.5 hours. This is what you can get from a box plot chart. As you can see here, data visualization tools can make a data analysis very easy to understand. Later in this semester, we'll learn how to draw other complicated charts. But here you want to remember that no matter which charts, graphs you draw in Python, in Pandas, in Jupyter, the first step you want to do is to import the visualization library. Import matplot library. This is the most important step we want to achieve before we perform data visualization.